Hi, everybody. In this video, I'm going to talk about a method of solving systems of equations called the elimination method. But before I get into that, I want to talk about something else, because as we use this method, we're going to be multiplying both sides of an equation by something, and we're also going to be doing something which we've never done before, which is adding one equation to another equation or subtracting an equation from another equation. And I just want to talk about why all of that makes sense. Okay, so first of all, something which we've talked about before, I'll just do a little bit of a review here. So this is a scale which represents the equation 2x equals 8. So we have two x boxes balancing out 8 stones, I'll call them, on the other side. And let's say that each stone is 1 pound. And here 3c equals 6. So we have 3c boxes balancing out 6 stones on the other side. And it's not hard to see that just one of these X boxes should weigh 4 pounds, okay? And we could also divide both sides by 2 here, and we would get X equals 4. And it makes sense to do that because if we think about this scale over here, if I cut the weight of this side in half, so first of all, if both sides of the scale have the same weight to begin with, then if I cut the weight of this side in half, then in order for them to still have the same weight, I would have to cut the other side in half also, right? So if they had the same weight to begin with, and then I made this side half as heavy and this side also half as heavy as it was before, then both of the sides that I have now should also weigh the same amount. They should also balance each other. So I have one X box balancing out 4 stones. And that could work with multiplication also. So let's go back here. Okay, so what if I were to multiply both sides by 2? Really, there's no reason for me to do that in this equation. That would not help me get the x by itself, but I could do it if I wanted to, just to prove a point, I guess. So if I had 2 x boxes and I multiply this side by 2, meaning I make it twice as heavy. So I'll just double what was there originally, and I'll also double this side. So I had 8 before. Let me put another 8 on there. Well, both sides here should also be balancing each other out, okay? One side would not tip over either to this side or this side, because if both sides were balanced before, and then I made both sides exactly twice as heavy, then it should still be balanced, okay? So multiplying or dividing both sides of an equation by the same number, hopefully this little diagram over here makes intuitive sense to you, so you understand why it makes sense to do that. But now something which we've never talked about before is adding one equation to another, but it should also make perfect sense. So let me just quickly sketch another scale over here. And you know what, before I throw things on here, let me tell you what I mean. So if I just add this equation to this one, and I'll just go, so 8 plus 6 is 14. And 2x plus 3c, well, these are not like terms. So I can't just say that this is 5x or something like that. But I could just put them next to each other like this. So 2x plus 3c. So I just added this. So 2x plus 3c, I have that over here. And 8 plus 6 is 14. Why does it make sense for me to do that? Well, going back to this picture over here, if I know that this exactly balances out this, and this exactly balances out this, then if I have another scale and I put on here, I'll put 3 of the C boxes and 2 of the X boxes, then that should completely balance out. Let's see, the 3 C boxes will balance out 6 stones, just like that. Well, I could do it. I could draw it that way. I just want to draw it the same way that I had over here. I don't really have to, but okay. And then these 8 stones over here are balancing out these two exponents. So if I just put this and this together on this side, and I put this together, this and this together on this side, hopefully you should be able to see that this side should balance this side out exactly. Okay, because this was the same as this, and this was the same as this. So this plus this should be the same as this plus this. If I just put all of this together on one side and all of this together on the other side, it should still balance out. So hopefully that makes sense. Hopefully now you understand why it actually does make sense to add one equation to another equation. All right. And the result that you get would also be a true statement. 2x plus 3c is equal to 14. We see that right over here. And it's the same for subtraction also. It's the same exact idea. If this is the same as this, and this is the same as this, then this minus this must be the same as this minus this. So I could also say that 2x minus 3c is equal to 8 minus 6, which is 2. Okay, that would also be a correct statement. All right, so now let's move on to the elimination method for solving systems of equations, which is going to involve everything that we talked about here, multiplying both sides of an equation by the same thing, or adding or subtracting one equation from another one. Okay, so now let's move on to the elimination method for solving systems of equations. So keep in mind, our goal here is to find a value for x and a value for y that we can plug into both of these equations to make both sides of each equation the same. Right? And here is just one strategy for doing that called the elimination method. So step one is to get the coefficients in front of either x or y to have the same absolute value in both equations using either multiplication or division. What do I mean by that? If I look at the coefficient in front of the x terms over here, I have a 32 in front of this x and a 4 in front of this x. They are not the same. If I look at the coefficients in front of the y terms, I have 16 over here and I have 3 over here. Okay, so those are also not the same. You could sometimes think of this as a -3 because minus is the same as plus -3, but that doesn't really matter right now. The point is the coefficients in front of the terms are not the same. So we want to get them to be the same. Now, how can I turn this 16 into a 3 by doing either multiplication or division? Well, that's not going to be very easy because 16 is not a multiple of 3. So I could try dividing the 16 by something to get 3, but whatever I divide by would have to be a fraction. So, for example, I could divide by 16 thirds. If I do 16 divided by 16 thirds, then remember, keep change flip. So that's like 16 times 3 over 16. And then these would cancel out. And I would get 3, just like I want over here. But I can't just divide this term alone by 16 thirds. I would have to also divide this by 16 thirds and this by 16 thirds. And it would just, I could do it, but it would just be very messy. So let's see if there's an easier way to do this where we don't have to use any fractions. Let's see if we can do it with just whole numbers. And luckily for us, 32 is a multiple of 4. So if I want to turn this 32 into a 4, I could just divide by 8. 32 divided by 8 is 4. All right, but I can't just single out this term over here. I'm going to have to divide both sides of this equation by 8, okay? Because remember, but this side used to be equal to this side. So if I slice this side into 8 equal pieces, then I need to slice this side into 8 equal pieces. I need to do the same thing to both sides to keep them balanced, right? Now, another way that we could have done this is instead of turning the 32 into a 4 by dividing by 8, I could have also chosen to just multiply this equation by 8 on both sides. So you could use either multiplication or division. I'm just going to use division for this example. So let's see what we get. If we do 32x divided by 8, that's going to give us 4x. And if we do 16y divided by 8, that's going to give us 2y. There was a plus sign here, so let's copy that. Equals, and now let's do 112 divided by 8. Okay, so that's going to give us 14 over here. Whoops. Alrighty, and so now let me just copy this over here. I just want them to be above and below each other. So I'll just copy that out. All right, so now I have successfully finished step 1, and I got the coefficients in front of the x terms to be the same. Okay, I could have done it with the y terms, but that would have been messier, so I did it with the x terms. Now, step 2 is to add or subtract one equation from the other to eliminate one of the variables. And since the x terms are the terms that now have the same coefficients, we're going to eliminate the x's from these in our result now. So now I have to decide, I'm going to either add or subtract this entire equation from this one. So how do I know if I should add or subtract? Well, I have to ask myself, I want these x terms to be eliminated. Okay, so is 4x minus 4x equal to 0? Because that's what I want. I want to eliminate it. I want to make it equal to 0. Or is 4x plus 4x equal to 0? Well, 4x plus 4x would be equal to 8x. So that's not what I want to do. I want to subtract them. So 4x minus 4x is equal to 0, which is what I want, okay? But I can't just subtract the 4x's. I have to subtract this entire equation from this one. So that means that I'm also going to have to do 2y, and then watch closely. I have 2y and then minus negative 3y. All right, so let me work that out on the side. 2y minus negative 3y. Minus negative turns into plus, and then I have 2y plus 3y, which is 5y. So positive 5y. So over here, I'm going to have plus 5y, okay? And then over here, again, be careful about this. We have 14 minus negative 31. So 14 minus negative 31 is like 14 plus 31, and that's going to give me 45. Okay, and this is 0 plus 5y. We don't actually even need to write the 0 over here, because 0 plus 5y is just the same as 5y. So we can just write the 5y. Now, at this point, now you might be getting a sense of why we did step 1 and step 2 in the first place. Because now that I have eliminated the x term, I only have y in this equation. So now I can just go ahead and solve for y. So I can just divide both sides by 5 over here. And then y is going to be equal to 9, right? 45 divided by 5 is 9. Okay, so I actually did step 3. So step 3 is solve for the variable that's still there. I did that. Okay, so y is equal to 9. So now I know what y is, so I'm almost done. Now I just need to figure out what x is. So step 4 is plug the value you found in step 3 into either equation. So either one of these equations will do. All right, so plug this value into either equation to solve for the other variable. So the other variable is going to be x. All right, so at this point, we can choose because it doesn't matter which one. So we can just choose the easier one. So I don't know. Does it look like it'll be easier to plug 9 into this equation or this equation? I think this equation looks a little bit easier, just the numbers are a little bit smaller. So let's plug it into that equation. Let me just write the equation out again. So 4x minus 3y equals negative 31. I'll plug 9 in for y. So I'll draw an arrow under the y and just replace it with a 9. So now I have 4x minus 3 times 9 equals negative 31. And then we're just going to solve this equation for x. So 3 times 9 is 27. So I have 4x minus 27 equals negative 31. I can add 27. So remember, inverse operations, this was subtraction here, so I need to do addition. So I'll add 27 to both sides. So I have 4x equals negative 31 plus 27. If I see that these symbols are different, I'm going to subtract them, and I'm going to keep the symbol in front of, whoops, that's a 2, and 2 minus 2 is nothing. Whoops, you didn't see me do that. So if we see that these symbols are different, we're going to subtract them, and we're going to keep the symbol in front of the larger number. So that was 31 is bigger than 20, the larger absolute value, really, I should say. 31 is bigger than 27. That had the negative in front of it. So my answer is not going to be 4. It's going to be negative 4. Okay, and then finally, to get rid of this 4, I'll divide by 4 and do the same thing on the other side. So x is equal to negative 4 divided by 4, which is negative 1. So I just figured out that x is equal to negative 1 and y is equal to 9. And if I just want to put it into that other form that we have, I could write it this way. Okay, the first number is always the x value, and the second number is always the y value. Now, do you remember what this y and this x are supposed to do for us? They're supposed to be a solution to both of these equations. So let's go ahead and plug them back into those equations just to see that they are, in fact, that both of them, that both of these equations are solved by these numbers. So over here we have, so my x is negative 1. So that would be 32 times negative 1 plus 16 times my y is 9 equals, so really, does this, did I do a good job? Is this side equal to this side? So that's why I'm putting the question mark here. But if I did a good job, then they should be the same. So 32 times negative 1, let me do it over here, is negative 32. 16 times 9, let's see here, that would be 54, and then 9 times 1 is 9, plus 5 is 14. So I have plus 144 over here equals 112, and then negative 32 plus 44 plus 144. I do 144 minus 32, and this 144 is bigger than 32, so I know my answer is going to be positive. And let's see here. Yeah, so this is going to give me a positive 112 on this side, and I already had positive 112 on that side, so that's good. So these two numbers, when I put them in here for x and y, it does solve this equation. Let's see if it solves the other equation. Let's see, so my x, make sure you're putting them into the right spot. The x is negative 1 minus 3 times the y is 9 equals negative 30, or does it equal? That's what we're trying to figure out here. So 4 times negative 1 is negative 4, minus 3 times 9 is 27, equals negative 31. Negative 4 minus, not 29, 27. Negative 4 minus 27. If these symbols are the same, then I'm going to add these two numbers up and keep the symbol. So my answer is going to be negative, and 27 plus 4 is 31. So I get negative 31 on this side, and I had negative 31 on this side, so that's good. So this is a solution to both of these equations, and therefore it is a solution to this system of equations. Right? Let's go ahead and do one more example. All right, so step 1, we want to get get the coefficients in front of either x or y, it's our choice, to have the same absolute value in both equations using either multiplication or division. All right, now, first of all, we see that this equation has the y term first and then the x term. This equation has the x term first and then the y term. All right, so really it's a good idea to just line. It's so much easier if we just line up the x's and the y's. So what I'm going to do is just reverse the order of this. So instead of negative 7y plus 2.5x, I can write 2.5x minus 7y. And this expression is equivalent to this expression. So it's okay to do that. Just make sure whenever you're doing something like that, that the symbols are the same. So I had a negative here. I still have a minus here in front of the 7y. Here I had a plus symbol in front of the 2.5x. And I didn't write it, but there's, if you don't see anything, then there's an invisible plus symbol, or I should say positive 2.5x right over there. All right, but usually we don't write it. I'm just going to erase that. Okay, equals 61. So now I have lined up my x's and I have lined up my y's. Let me just cross that out because it's just messy to look at both. All right. So step one is we want to get the coefficients in front of either x or y to have the same absolute value using either multiplication or division. So let's see, is there an easy way that we can do that? Last time we looked at the x terms, but this is 2.5, this is 6. It doesn't look like there's an easy way for me to multiply this by something to get 6, or for me to divide 6 by something to get 2.5. And also, I look at the y terms here, and 7 is not a multiple of 2. So I can't multiply 2 by at least a whole number to get 7, and I can't divide 7 by a whole number, which would be easier, to get 2. So here's what we're going to do. This is actually similar to what would you do. Let me sort of go off on a little bit of a tangent here. What would you do if you wanted to add 3/7 and let's say 5/2? Okay, well, the denominators have to be the same when you're adding fractions, right? So hopefully, if you remember all of your lessons about fractions, in order to get the denominators the same here, what we could do is we could multiply the numerator and denominator of this fraction by this denominator. And we could also multiply the numerator and denominator of this fraction by this denominator. Okay, and that would give us 6 over 14 plus 35 over 14, which would be equal to 41 over 14, right? Okay, so that's how we would do it with fractions. We're actually going to do something very similar over here. If I want the coefficients in front of, let's say, my y terms to be the same, I could use the same sort of trick, and I could multiply both sides of this equation by this coefficient, 2, and I could multiply both sides of this equation by this coefficient of 7. All right, let's put a dot there for multiplication. All right, so let's go ahead and do that. So 2 times 2.5x is going to give me 5x. 2 times negative, well, 2 times, I can treat this like a negative. So 2 times negative 7, because minus 7 is the same as plus negative 7. That's why I can treat it like a negative. So 2 times negative 7 is negative 14. And that's, so I can say that this is like minus 14y. Equals, this is going to give me 122. And then here I have 7 times 6x is 42x. And 7 times 2y is 14y. It's going to give me plus 14y. Equals negative 4 times 7 is going to give me negative 28. All right. Now, now that I have the absolute values of both of these coefficients are the same, if I think of this as a negative, like plus negative 14, then the signs are different, but the absolute values are the same. The absolute values for both of them are 14. Okay, so I have achieved step one. Now for step two, I have to add or subtract this equation. I have to either add it to this one or subtract it from this one in order to eliminate one of the variables. In this case, since I got these coefficients to be the same, I'm going to be eliminating the y. So I have to ask myself, is negative 14, think of this like a negative, okay? Is negative 14 plus positive 14 equal to 0? Does that eliminate it? Or is negative 14 plus, or is negative 14 minus positive 14 equal to 0? Well, the answer is that negative 14 plus positive 14 is equal to 0. All right, and that's what we want. So we're going to have to add this whole equation to this one in order to get these to cancel out, so for the y's to be eliminated. All right, so now I also have to do 5x plus 42x is going to give me 47x, right, plus 0, which really I don't even need to write because 47x plus 0 is just the same as 47x. So we don't actually have to write that plus 0 there. And then 122 plus negative 28. So let's write that out over here. 122 plus negative 28. Well, when we add a negative, that's like subtracting a positive 28. So I have here 122 minus 28, and that's going to give me 94, right? Okay, so this over here is going to be 94. And then I'm just going to divide to solve for the x here. Again, the whole point of doing step one and step two and eliminating one of the variables is because now I have an equation with just one variable in it, so I can easily solve this equation and figure out what x is. So if I divide both sides by 47, then I'll get x equals 94 divided by 47 is 2. 47 goes into 94 twice. Okay, so now I know that x is 2, and I have to figure out what y is. And in order to do that, again, I already did step 3. I solved for the variable that's still there. The variable that was still there was x, and I solved for x, so I know that x is 2 now. So now moving on to step 4, plug the value you found in step 3 into either equation to solve for the other variable. So let's go ahead and do that. And we can use, let's go back to the equations that we had in the beginning. We can use either equation here, okay? So let me just look at which equation looks simpler, because I can use either one. So this one looks a little bit simpler. So I'll just plug the 2 in for x over here, and I'll get 6 times 2, so my x is 2, plus 2y equals negative 4, so that's going to give me 12 plus 2y equals negative 4. So I have a 12 here, which is a positive 12, which I can treat as addition, and I can do the inverse of addition and subtract 12 from both sides. So I get 2y equals negative 4 minus 12. If I see that these symbols are the same, I would add up these absolute values and keep the symbol. So that's going to give me negative 16 here. And now my final step is I'll divide both sides by 2, and I'll get y equals negative 16 divided by positive 2 is negative 8. Okay, and again, let's just go ahead. So now I'm done, really. The only thing that I want to do is check my answers. So does this solution of 2, negative 8 actually solve both of these equations? Well, let's see. So if I be careful here, so my y is negative 8 plus 2.5x, my x is 2, is that equal really to 61? Let's see. This is going to give me positive 56. 2.5 times 2 is 5. Okay, and 56 plus 5 is 61. So I get 61 equals 61. That's good. What about the other equation? So I'll plug, which one did I just did this one, right? Okay, so 6. So careful, my x is 2. So I'll plug 2 in there. Plus 2 times my y is negative 8. Is this really equal to negative 4? Let's see. That's 12 plus 2 times negative 8 is negative 16. When I add a negative, that's like subtracting. So 12 minus 16, is that equal to negative 4? Let's see. 12 minus 16 is negative 4. So I get negative 4 on the left side, and I had negative 4 on the right side all along. So that is good. So this is the solution to both of these equations. So this method works. All right, that's it, and have a great day.